Exponential functions, learning target 3A. We need to work on creating equations for exponential functions. Remember, we have y equals my y-intercept times my common ratio raised to the x. Let's go ahead and find my y-intercept for my first graph. I look where I have my 0, and whatever is with my 0 is my y-intercept. So I have y equals 25 times, and then I need to find my common ratio. I start with 5, then I go to 25 to 125. Each time I'm multiplying by 5, so times 5 to the x. Looking at my second graph, I try and find my y-intercept. My y-intercept is with my 0 for my x, so y equals 7 times, I go from 1 to 7 to 49, so I multiply by 7. So times 7 to the x is my equation. Here are two more examples. I find my y-intercept, which is with my 0, and that is 1. So I have y equals 1 times, I go from 3 to 1 to 1/3. Every single time I divide by 3. Remember, we need to change that into a times. So the opposite of divide by 3 over 1 is times by 1 over 3 to the x. Looking at the second one, my y-intercept is going to be 4. So y equals 4 times, I go from 16 to 4 to 1. So I am dividing by 4. Remember, I need to be timesing, so instead of dividing by 4 over 1, I'm timesing by 1 over 4 to the x. Here is an in-context problem. It says North High School has 130 teams competing in a tournament. After each hour, half of the teams are eliminated, so we need to write the equation. I know 130 and half is what I'm going to use. So y equals my y-intercept, which is what I start with, so 130, times my common ratio, so each hour I am losing a half. Now it wants to know after 2 hours how many teams will remain. So I have y equals 130 times 1/2, and instead of an x, I'm putting a parentheses 2. I figure out that I will have 32.5 teams. A few ways you can go about this is saying that after 2 hours, they will have, and we have to round. And remember, if we have 0.5 of something, we're going to round down, so 32. 32 teams. Otherwise, you can say this isn't possible because you can't have 0.5 of a team.